This is, we have question number 6. We have question number 6. So a train covers covers 600 kilometer 600 kilometer with a speed of with a speed of speed of x kilometer per hour, x kilometer per hour, right? X kilometer, a train covers 600 kilometer with a speed of x kilometer per hour. So how much time it will take? T1 is equal to distance upon speed, right? Time is equal to distance upon speed. So this is 600 kilometer upon x kilometer per hour. So this kilometer goes on cut off, and this will go up. It becomes 600 x 600x hours. This much time it takes, right? Initially, what happens now? What is written there? Now, had the speed been x plus 20 kilometer, the time taken to cover the distance would have been reduced by 5 hours. If if speed if speed becomes x plus 20 kilometer per hour 20 kilometer per hour, then time taken to cover distance is 5 hours 5 hours less 5 hours less. Is it? Same thing is written there, na? What I'm saying?
Yes.
So now T2 is what? T2 is, distance is same, 600 kilometers 600 kilometer upon x plus 20 kilometers per hour. फिर it becomes 600 upon 20x plus 20 hours. This much time. And the difference between these, मतलब T2 is 5 hour less than the 5 hour less than the T1. So T2 is equal to T1 minus 5 hour. What is written there? Obviously, when speed will increase, then it takes less time. So when it is moving with the speed of x plus 20 kilometer per hour, then it takes 5 hours less time to reach the to cover the given distance, right? So now we put the values here. So what happens? This is 600 upon x plus 20 is equal to 600 upon x minus 5. You get this? Now what do? You bring this part, this 600 plus 20, this you bring on this side, it turns to be minus, and bring this minus 5 on this side, it turns to be plus. It is plus, it is minus, right? So we can write in that way that 600, we can write here 600 upon x minus 600 upon x plus 20 is equal to 5, right? You have taken x bracket x plus 20 as a LCM, then what happens? This x cancel, this becomes 600 x plus, it becomes how much? 12,000, huh? 12,000 minus 600x is equal to 5. So that's this plus 600x minus 600x is gone, and you know this one time 5 becomes 5, and this is 2 times 5 becomes 10, 4 times 5 becomes 20, and 2 0. You get it like this? This is. Now what we do, we cross multiply the things, then we get x square plus 20x minus 2400 is equal to 0. You get it? Is this correct? So 60 into 40 is how much? 24, na? No, 60 into 40 is 60 into 40 means 2400, right? Matlab, if we write 60 into 40, we get 2400, right? And 60 minus 40, we get 20. This is the rough we have done, right? So what we can write here? We can write here x square plus 60x minus 40x minus 40x minus 2400 is equal to 0. So what you do, you take x as a common, so it becomes x plus 60 bracket minus 40 you have taken as a common, it becomes x plus 60. You get it? So you get at last x plus 60 bracket x minus 40 is equal to 0. Right? Now what we can do, if we take x plus 60, if we take x plus 60 is equal to 0, so x is equal to minus 60. So not applicable. Not applicable. Not applicable. Right? Now we have x minus 40 is equal to 0, so it becomes x is equal to 40. So you get how much? So speed of train is equal to x kilometer per hour, or it is 40 kilometers per hour. Do you get this? So this is your answer. I hope you understand this question. You done this? Huh? Okay. Very good. Very nice. Okay. Okay. Can you do this question number 8? Can you do the question number 8? Question number 10 is like this. What is question number 10? Right? Given equation has equal roots. What is the meaning of it? Equal roots means discriminant is equal to 0. Right? Or you can say b square minus 4ac is equal to 0. This is the meaning of this statement. And you have to find value of z, find value of z. And what is the equation?
Z minus 2.
That is z minus 2 x square minus 5 plus z x plus 16 is equal to 0. This is the equation. So, What is it? This is A, right? What is it?
B.
This is B, and this is C, right? As we know, B square minus 4AC is equal to 0. Now we substitute the values. So B square means
5 plus Z.
minus 5 plus Z whole square minus 4 into Z minus 2 into
16.
16, right, is equal to 0. This is this is we have. If I take here 1, if I write here minus 1, think it's same, right? Minus 1 square is
1.
1. So it will be 1. So now what you can do, you can do, you can write this minus 1 whole square is 1 bracket, this is 25 plus Z square plus 10Z, right, minus 64 Z plus 128 is equal to 0. Is it? 4 times 16 becomes 64, and 64 into 2 becomes 128, minus minus plus, and this is 64 minus 64 into Z becomes minus 64Z, and this goes to be 1, this turns to be 1. So finish. Now we have 25 plus Z square plus 10Z plus 10Z minus 64Z plus 128 is equal to 0. You get it? Now what you will do now? Now we will rearrange the things. When you rearrange the things, then you get Z square plus 10Z minus 64Z plus 25 plus
Plus 21, 20.
hmm,
Plus 21.
plus 128 is equal to 0. So now we get how much? Z square minus 54Z plus 153 is equal to 0. You get this? Now how you will solve? Now 153 is divided by 3, right? Yeah, you get that. 51, 5 times 3 becomes 15 and 1 times 3 becomes 51. Then 51, then again you go by 3. 1 time
3 and
1
21,
time
7.
3 and you get 7. 7 is a prime number. It will not go further. Finish. Right? Now what we can do?
3
Again, 3 times 51 is, hello,
is
3 times 51 is 153. 51 plus 3 is how much?
54.
You get 54. So you write here, you will write here z square minus 51 plus 3 plus 3 z plus 153 is equal to 0. You get it? Now what next we have? That we have z square minus 51z minus 3z plus 153 is equal to 0. So you get z as a common, you get z minus 51 minus 3 bracket z minus 51 is equal to 0. Right? So what do you get? What do you get?
Z is equal to 51.
So z minus 51 we have taken as a common. You get z minus 3 is equal to 0. After that, if I take z minus 51 is equal to 0, so z is equal to 51, and if z minus 3 is equal to 0, so z is equal to 3. So values of z are z is equal to 51 and 3. Is it? This is how to solve. You understand this? Hmm? Should I rub?
Yes.
Okay. Now you come to ratio proportion. Remaining you try to do by your own. Otherwise I'll again come on some other day. There are so many questions on this. Okay. Question number 1, how you will do that? X, Y, Z are continued proportion. Yeah. Question number, this is 11. X, Y, and Z are in continued proportion. Continued proportion. Proportion. Right. Prove. Prove x plus y. X plus y whole square upon y plus z whole square is equal to xy. Xy. Right? This we have to prove. So how you will do it? They are in continued proportion, na? So if I write x upon y is equal to y upon z is equal to k, right? So what you can write here? We can write x upon y is equal to k. So x is equal to ky, right? Okay. And if I write y upon z is equal to k, then y is equal to we get kz. When it is k, y is equal to kz, so when we put this value here, this value of y we will put here, so x becomes k bracket kz, so it is, so x is equal to k square z, y is equal to kz, and z is equal to z. That is okay, right? We done that. Now come to this. So we have, you know, if I go LHS, LHS is x plus y whole square upon y plus z whole square. Then what happens? What is the value of x? Hmm? K square z, hmm? plus y is equal to kz whole square upon, this is what, y is equal to kz plus z whole square. You get it? Now what you will do? You take kz common from here. When you take kz from common from here, so it becomes we have k square we will have k square z square common from here. Then we get k plus 1, right? It is whole square. Getting my point? And when you are taking from here, so it is, you are taking z square common from here. So you get k plus 1 whole square, right? So this k square plus 1 is gone off, and z square is gone off. So it is, so LHS is equal to k square. Getting? Hmm? Now RHS is equal to x upon y. So x is equal to k square z upon y is equal to kz. Fine. Hmm. So this is z, and z is common, and k is gone. You get k here. Okay. If we do the expansion of this, if we do the expansion of this, then what happens? This LHS. This is k raised to the power 4, right? K raised to the power 4 into z square plus k square z square plus 2 in a into b होता है ना, a b होता है. So it becomes 2 k cube z square, right? This is the expansion, and when we expand this, Then what happens? K square z square plus z square plus 2 kz square. You get it? Just look at here. Right. Now what you do, if we take lowest power,
2.
k raised to the power 2, k raised to the power 2 z square, we have taken as a common. Then what will be? This is k raised to the power 2, right? Plus 1 plus 2k upon if I write, if I take z square from here, it is common, then it becomes k square plus 1 plus 2k, right? So now this is cancelled out by this, they are cancelled, and this z square is gone to z square. So LHS is equal to,
K.
so it means this LHS is equal to K. LHS is equal to K square. K square. I hope it is written wrong here. Right? Nothing we can do with this. This is, LHS is equal to K, blue and blue is over. So it is, we get K square. LHS we get K square. Now if we take RHS, RHS is equal to x upon z. So it becomes z is equal, x is equal to k square upon z upon z. So z is gone and you get k square. Right. So LHS is equal to RHS is equal to k square. Hence true. So it should be z here. It should be z. Right. It should be z. Not this. Otherwise it cannot be proved. If you take x upon y, so it is coming, I expanded that. Earlier I did the same, I got the same, but I expand and then I put the values and then I am finding the k square is there. No way we are getting k. Right. Actually when we take common always lowest value. The lowest value of k is k square. So I take k square. Lowest value of z is z square. So I take z square. After that, what we are getting? We are getting the same k square plus 1 plus 2 k. So it's not possible. So it means there is a printing mistake there. It must be x upon j. Then we can reach to here. Right? I hope this must be. So this is the question. Should I now?
Yes.
Okay. One more. We have given
Um,
question number 2, right? There is x square is equal to root a square plus b square plus root a square minus b square upon we have a square, we have root over, can you read, a square
plus b square
plus b square
minus a square
minus a cube
a square.
a square minus b square. This is the question, right? Then what we have to use, componendo dividendo, prove that, okay, so prove that prove that prove that x square is equal to 2ax 2a square x upon x square plus 1, x square plus 1. You get this? This we have to prove. So by applying componendo and dividendo, right, what happens? It becomes, we take 1 here, so it is x plus 1 upon x minus 1 is equal to root over a square plus b square plus root a square minus b square plus root a square plus b square minus root a square minus b square upon root a square plus b square plus root a square minus b square minus a square plus b square plus root a square minus b square. You get this? Now this plus and this minus is gone. This plus and this minus is gone. So you get x plus 1 upon x minus 1 is equal to 2 bracket root a square plus b square upon 2 bracket a square a square minus b square. You get this? This 2 and 2 is gone off. Now taking square both sides. Taking square both sides. So what happens? It becomes x square plus 1 plus 2x upon x square plus 1 minus 2x is equal to, when we take it, it becomes a square plus b square upon a square minus b square. Right? Now, by again applying componendo and dividendo. Dividend. Right? Then what happens? Then it becomes x square plus 1 plus 2x plus x square plus 1 minus 2x upon x square plus 1 plus 2x minus x square minus 1 plus 2x is equal to a square plus b square plus a square minus b square upon a square plus b square minus a square plus b square. You get it? So again what we do, this plus b square minus b square is cancelled, or a square minus a square is cancelled, and here minus 2x is cancelled. It is minus x square minus x square plus square minus x square is cancelled. So what you get at last? You get 2x square 2x square 2x square plus 2 upon, you get
4x
4x is equal to how much? 2a square upon
2b
2b square. This 2 and 2 is cancelled out, and if we have taken 2 common from here, it is x square plus 1 upon 4x. It becomes 2x, right, is equal to a square upon b square. You get this? Hmm? Yeah, wait. This 2 is cancelled, this 4, 2 times 2 becomes 4, we get 2x. So finally you get the equation. So final equation which you get, that is x square, you get x square plus 1 upon 2x. 2x is equal to a square upon b square. What we have to prove?
x square is equal to 2a square x upon x square is
It is again written wrong here. It should be b square. It is written wrong. Where will go with this b, man? Right? Now you cross multiply. When we cross multiply, we multiply it with this and we multiplied it with this. So we will get, you know, b square bracket x square plus 1 is equal to 2 2a square x. You get this, right? And finally, when you bring it like this is b square is equal to 2a square x upon x square plus 1. This is. So hence, oh, there is wrong.